Hello guys, what is up? Today I am doing a video on intermolecular forces. Great, so let's get into it. Okay, so what are the three main types? Before we get into all three main types, we'll just start with one of them, and that is London dispersion. So first of all, what is London dispersion forces? How do they work? What are they? Most students just see this in their textbook and they're like, oh, well, I know they exist, but what are they? Okay, so like one good thing to keep in mind is that they are in every single molecule. So every molecule has these types of bonds. So remember that first of all. And now I'll go over to what they are. So if we have these two molecules right here, right, they're methane. But anyways, this carbon has an electronegativity around 2.5. Hydrogen has it around 2.1. What does electronegativity mean? A slight pull of electrons, more towards carbon because it's higher. So there's going to be times, and this force is extremely weak, by the way. I'm going to write the weakest of the force. The weakest, remember that. All right. There's going to be times where this carbon right here is going to hog hydrogen's electrons a little bit more so. Okay? And there's going to be, so that's going to leave a delta negative towards the carbon and a delta positive over here towards the hydrogen. Okay? And sometimes the hydrogen will pull on the carbon just a little bit. So there's going to be a delta negative on this hydrogen and a delta positive on this carbon. All right. So this attraction right here between the positive and the negative is what a London dispersion force is. This is super weak. Like molecules kind of do this. They kind of fluctuate throughout, but students normally aren't tested too much on how they work, but it's just good to know what these types of forces are. Okay, now moving on to the second type of force. It's going to be called the dipole force. And what are they? They are difference in electronegativity. So, for example, oxygen has a electronegativity around 3.0. Hydrogen has electronegativity around 2.1. So is there a dipole in this molecule? Well, yeah, it's going to be going this way. So the dipole arrow is going up. This is super important because there's going to be a negative side, and there's going to be a positive side. And then if this happens two times on the molecule, so this is negative, this is positive, we have this attraction right here. And these are going to be medium strength. So they're definitely going to be stronger than dispersion forces because they kind of fluctuate throughout. These dipole forces, they're there to stay. Okay, but something that can affect the dipole, however, is the symmetry. So let's say we've drawn H2O like this. HOH. Or like, hey, well, there's no net charge. Like, this one's going this way, this one's going this way. They should cancel out. So this is where it's important to know your molecular and electron geometry. So in H2O, we should already know that the shape is going to be tetrahedral. So tetrahedral should look something along the lines of this. 1, 2, 3, 4. All right. And if we have electrons at two spots, we're going to cross off any two circles. So I'll cross off this one and this one. So this leaves us with the shape. Trying to get a different color. So oxygen right here, attached with the hydrogen, attached with the hydrogen. This gives it a bent shape, and these should be lone pairs. Students mess up all the time thinking it's something like this. No. The actual molecule looks something like this, and it's important to know your electronic geometry. Next, we're going to go into hydrogen bonding. Yay. Okay, so what is hydrogen bonding and when does it happen? Well, the hydrogen that is participating in the hydrogen bond must be attached to, this is fluorine, oxygen, or nitrogen. Okay? And keep in mind, it's an intermolecular force. Intermolecular forces happen between two different molecules, not within the same molecule. Just keep that in mind. All right. So I'm going to be testing you right now. Is this force, or is this bond right here a hydrogen bond? This hydrogen connecting with this oxygen, is that a hydrogen bond? The answer is no, that is not a hydrogen bond. This is a covalent bond. Keep that in mind. It's a covalent bond. How about this? Is this a hydrogen bond? No, that is a covalent bond. Hydrogen bonds are intermolecular forces. So, now I'm going to give you another question. Is this right here a hydrogen bond? The answer to that is no. Why is that? Because if we look at this roll over here, the H that is participating must be attached to fluorine, oxygen, or nitrogen. This H that is participating is attached to a carbon. So therefore, this is not a hydrogen bond. Now let's move over here. Is this a hydrogen bond? This hydrogen with this oxygen. So let's read the rule. Is the hydrogen that is participating attached to any of these? The answer is yes. This hydrogen is attached to oxygen, and also one of these must be capturing the hydrogen as well. So this right here, it is a hydrogen bond. And to finally test you, is this a hydrogen bond? And the answer to that is yes. It's the same exact one we're just looking at, but just inversed. All right. So now I'm going to test you. So what type of forces do these molecules have? So let's look at number one. So what do you guys think? Before I give you the answer, try to do this by yourself. And the answer to that is that it has all types of forces. So as we can see, there's a dipole. There's hydrogen bonding. Let's look at this. This hydrogen with this nitrogen. That's actually hydrogen bonding. This hydrogen, I don't know what happened right there. Okay, whatever. There we go. All right, this hydrogen with this nitrogen, that's hydrogen bonding. All right, there's a dipole. And then what else does it have? It has London dispersion forces. Why? Because every molecule has London dispersion forces. So I'm just going to write London dispersion, dipole, and then H bond. So it has all three. What about this one? So the answer to that is going to be, no, it's the other way. Or no, okay, so no, I drew it correctly. Okay, so it's going to have a dipole. And a dipole and what else? London dispersion, because they all have London dispersion. So London, and then dipole. And then finally, this very last one. So what do these have? Well, they're symmetrical. They don't really have a dipole on them. So what kind of force would they have? They are going to be just a London dispersion. London dispersion. By the way, London dispersion, same thing. So this is a quick rundown for what you should know about intermolecular forces. If you do not understand any of this, feel free to give this video another watch until you do, or ask a tutor. Thank you for watching.